terrestrial environment, the effects of gravity on space and time are so small that they are insignificant. But in astrophysics, which deals with extremely massive bodies like planets, stars, and galaxies, the curvature of space-time is an important phenomenon. All observations have so far confirmed Einstein's theory, and thus force us to believe that space-time is indeed curved. The most extreme effects of the curvature of space-time become apparent during the gravitational collapse of a massive star. According to current ideas in astrophysics, every star reaches a stage in its evolution where it collapses due to the mutual gravitational attraction of its particles. Since this attraction increases rapidly as the distance between the particles decreases, the collapse accelerates, and if the star is massive enough, that is, if it is more than twice as massive as the Sun, no known process can prevent the collapse from going on indefinitely. As the star collapses and becomes more and more dense, the force of gravity on its surface becomes stronger and stronger, and consequently the space-time around it becomes more and more curved. Because of the increasing force of gravity on the star's surface, it becomes more and more difficult to get away from it, and eventually the star reaches a stage where nothing, not even light, can escape from its surface. At that stage, we say that an event horizon forms around the star, because no signal can get away from it to communicate any event to the outside world. The space around the star is then so strongly curved that all the light is trapped in it and cannot escape. We are not able to see such a star because its light can never reach us. For this reason, it is called a black hole. The existence of black holes was predicted on the grounds of relativity theory as early as 1916. They have lately received a great deal of attention because some recently discovered stellar phenomena might indicate the existence of a heavy star moving around some unseen partner, which could be a black hole. Black holes are among the most mysterious and most fascinating objects investigated by modern astrophysics, and illustrate the effects of relativity theory in a most spectacular way. The strong curvature of space-time around them prevents not only all their light from reaching us, but has an equally striking effect on time. If a clock, flashing its signals to us, were attached to the surface of the collapsing star, we would observe these signals to slow down as the star approached the event horizon. Once the star had become a black hole, no clock signals would reach us anymore. To an outside observer, the flow of time on the star's surface slows down as the star collapses, and it stops altogether at the event horizon. Therefore, the complete collapse of the star takes an infinite time. The star itself, however, experiences nothing peculiar when it collapses beyond the event horizon. Time continues to flow normally, and the collapse is completed after a finite period of time, when the star has contracted to a point of infinite density. So how long does the collapse really take? A finite time or an infinite time? In the world of relativity theory, such a question does not make sense. The lifetime of a collapsing star, like all other time spans, is relative and depends on the frame of reference of the observer. In the general theory of relativity, the classical concepts of space and time as absolute and independent entities are completely abolished. Not only are all measurements involving space and time relative, depending on the state of motion of the observer, but the whole structure of space-time is inextricably linked to the distribution of matter. Space is curved to different degrees, and time flows at different rates in different parts of the universe. We have thus come to apprehend that our notions of a three-dimensional Euclidean space and of linear flowing time are limited to our ordinary experience of the physical world and have to be completely abandoned when we extend this experience. The Eastern sages, too, talk about an extension of their experience of the world in higher states of consciousness, and they affirm that these states involve a radically different experience of space and time. They emphasize not only that they go beyond ordinary three-dimensional space in meditation, but also, and even more forcefully, that the ordinary awareness of time is transcended. Instead of a linear succession of instants, they experience, so they say, an infinite, timeless, and yet dynamic present. In the words of D.T. Suzuki, quote, "In this spiritual world there are no time divisions such as the past, present, and future, for they have contracted themselves into a single moment of the present where life quivers in its true sense. The past and the future are both rolled up in this present moment of illumination, and this present moment is not something standing still with all its contents, for it ceaselessly moves on." Unquote. Physicists say that in the actual world, each observer can only experience the phenomena in a succession of space-time sections, that is, in a temporal sequence. Mystics, on the other hand, maintain that they can actually experience the full span of space-time where time does not flow any longer. Thus, the Zen master Dogen said, quote, "It is believed by most that time passes. In actual fact, it stays where it is. This idea of passing may be called time, but it is an incorrect idea, for since one sees it only as passing, one cannot understand that it stays just where it is." Unquote. Many of the Eastern teachers emphasize that thought must take place in time, but that vision can transcend it. As Govinda says, "Vision is bound up with a space of a higher dimension and is therefore timeless." The space-time of relativistic physics is a similar timeless space of a higher dimension. All events in it are interconnected, but the connections are not causal. Similarly, the Eastern mystics assert that in transcending time, they also transcend the world of cause and effect. Like our ordinary notions of space and time, causation is an idea which is limited to a certain experience of the world and has to be abandoned when this experience is extended. In the words of Swami Vivekananda, quote, "Time, space, and causation are like the glass through which the Absolute is seen. In the Absolute, there is neither time, space, nor causation." Unquote. The Eastern spiritual traditions show their followers various ways of going beyond the ordinary experience of time and of freeing themselves from the chain of cause and effect, from the bondage of karma, as the Hindus and Buddhists say. It has therefore been said that Eastern mysticism is a liberation from time. In a way, the same may be said of relativistic physics. The more one studies the religious and philosophical texts of the Hindus, Buddhists, and Taoists, the more it becomes apparent that in all of them, the world is conceived in terms of movement, flow, and change. This dynamic quality of Eastern philosophy seems to be one of its most important features. The Eastern mystics see the universe as an inseparable web whose interconnections are dynamic and not static. The cosmic web is alive. It moves, grows, and changes continually. Modern physics, too, has come to conceive of the universe as such a web of relations, and like Eastern mysticism, has recognized that this web is intrinsically dynamic. The dynamic aspect of matter arises in quantum theory as a consequence of the wave nature of subatomic particles, and is even more essential in relativity theory, where the unification of space and time implies that the being of matter cannot be separated from its activity. The properties of subatomic particles can therefore only be understood in a dynamic context, in terms of movement, interaction, and transformation. Remember that according to quantum theory, particles are also waves, and this implies that they behave in a very peculiar way. When a subatomic particle is confined to a small region of space, it reacts to this confinement by moving around. The smaller the region of confinement, the faster will the particle jiggle around in it. This behavior is a typical quantum effect, a feature of the subatomic world which has no macroscopic analogy. The tendency of particles to react to confinement with motion implies a fundamental restlessness of matter, which is characteristic of the subatomic world. In this world, most of the material particles are bound to the molecular, atomic, and nuclear structures, and therefore are not at rest, but have an inherent tendency to move about. They are intrinsically restless. According to quantum theory, matter is thus never quiescent, but always in a state of motion. Macroscopically, the material objects around us may seem passive and inert, but when we magnify such a dead piece of stone or metal, we see that it is full of activity. The closer we look at it, the more alive it appears. All the material objects in our environment are made of atoms which link up with each other in various ways to form an enormous variety of molecular structures. These are not rigid and motionless, but oscillate according to their temperature and in harmony with the thermal vibrations of their environment. In the vibrating atoms, the electrons are bound to the atomic nuclei by electric forces which try to keep them as close as possible. They respond to this confinement by whirling around extremely fast. Finally, in the nuclei, the protons and neutrons are pressed into a minute volume by the strong nuclear forces and consequently race about with unimaginable velocities. Modern physics, then, pictures matter not at all as passive and inert, but as being in a continuous dancing and vibrating motion whose rhythmic patterns are determined by the molecular, atomic, and nuclear structures. This is also the way in which the Eastern mystics see the material world. They all emphasize that the universe has to be grasped dynamically, as it moves, vibrates, and dances. They emphasize that nature is not in a static, but a dynamic equilibrium. In the words of a Taoist text, quote, "The stillness in stillness is not the real stillness. Only when there is stillness in movement can the spiritual rhythm appear which pervades heaven and earth." Unquote. In physics, we recognize the dynamic nature of the universe not only when we go to small dimensions, to the world of atoms and nuclei, but also when we turn to large dimensions, to the world of stars and galaxies. Through our powerful telescopes, we observe a universe in ceaseless motion. Rotating clouds of hydrogen gas contract to form stars, heating up in the process until they become burning fires in the sky. When they have reached that stage, they still continue to rotate, some of them ejecting material into space which spirals outwards and condenses into planets circling around the star. Eventually, after millions of years, when most of its hydrogen fuel is used up, a star expands and then contracts again in the final gravitational collapse. This collapse may involve gigantic explosions and may even turn the star into a black hole. All these activities, the formation of stars out of interstellar gas clouds, their contraction and subsequent expansion, and their final collapse, can all actually be observed somewhere in the skies. The spinning, contracting, expanding, or exploding stars cluster into galaxies of various shapes, flat disks, spheres, spirals, etc., which, again, are not motionless, but rotate. Our galaxy, the Milky Way, is an immense disk of stars and gas turning in space like a huge wheel, so that all its stars, including the Sun and its planets, move around the galaxy's center. The universe is, in fact, full of galaxies strewn through all the space we can see, all spinning like our own. When we study the universe as a whole, with its millions of galaxies, we have reached the largest scale of space and time. And again, at that cosmic level, we discover that the universe is not static, it is expanding. This has been one of the most important discoveries in modern astronomy. A detailed analysis of the light received from distant galaxies has shown that the whole swarm of galaxies expands, and that it does so in a well-orchestrated way. The recession velocity of any galaxy we observe is proportional to the galaxy's distance. The more distant the galaxy, the faster it moves away from us. At double the distance, the recession velocity will also double. This is true not only for distances measured from our galaxy, but applies to any point of reference. Whichever galaxy you happen to be in, you will observe the other galaxies rushing away from you. Nearby galaxies at several thousand miles per second, farther ones at higher speeds, and the farthest at velocities approaching the speed of light. The light from galaxies beyond that distance will never reach us. because they move away from us faster than the speed of light. Their light is, in the words of Sir Arthur Eddington, like a runner on an expanding track with the winning post receding faster than he can run. To have a better idea of the way in which the universe expands, we have to remember that the proper framework for studying its large-scale features is Einstein's general theory of relativity. According to this theory, space is not flat, but is curved, and the precise way in which it is curved is related to the distribution of matter by Einstein's field equations. These equations can be used to determine the structure of the universe as a whole. They are the starting point of modern cosmology. When we talk about an expanding universe in the framework of general relativity, we mean an expansion in a higher dimension. We can visualize such a concept with the help of a two-dimensional analogy. Imagine a balloon with a large number of dots on its surface. The balloon represents the universe, its two-dimensional curved surface representing the three-dimensional curved space. The dots on the surface are the galaxies in that space. When the balloon is blown up, all the distances between the dots increase. Whichever dot you choose to sit on, all the other dots will move away from you. The universe expands in the same way. Whichever galaxy an observer happens to be in, the other galaxies will all move away from him. As far as the future of the expanding universe is concerned, Einstein's equations do not provide a unique answer. They allow for several different solutions corresponding to different models of the universe. Some models predict that the expansion will continue forever. According to others, it is slowing down and will eventually change into a contraction. These models describe an oscillating universe, expanding for billions of years, then contracting until its total mass has condensed into a small ball of matter, then expanding again, and so on without end. This idea of a periodically expanding and contracting universe, which involves a scale of time and space of vast proportions, has arisen not only in modern cosmology, but also in ancient Indian mythology. Experiencing the universe as an organic and rhythmically moving cosmos, the Hindus were able to develop evolutionary cosmologies which come very close to our modern scientific models. One of these cosmologies is based on the Hindu myth of Leela, the divine play, in which Brahman transforms himself into the world. Leela is a rhythmic play which goes on in endless cycles, the one becoming the many, and the many returning into the one. In the Bhagavad Gita, the god Krishna describes this rhythmic play of creation in the following words, quote, "At the end of the night of time, all things return to my nature. And when the new day of time begins, I bring them again into light. Thus, through my nature, I bring forth all creation, and this rolls around in the circles of time. But I am not bound by this vast work of creation. I am, and I watch the drama of works. I watch, and in its work of creation, nature brings forth all that moves and moves not. And thus the revolutions of the world go round." Unquote. The Hindu sages were not afraid to identify this rhythmic divine play with the evolution of the cosmos as a whole. They pictured the universe as periodically expanding and contracting, and gave the name Kalpa to the unimaginable time span between the beginning and the end of one creation. The scale of this ancient myth is indeed staggering. It has taken the human mind more than 2,000 years to come up again with a similar concept. So far, our exploration of the worldview suggested by modern physics has repeatedly shown that the idea of basic building blocks of matter is no longer tenable. In the past, this concept was extremely successful in explaining the physical world in terms of a few atoms, the structures of the atoms in terms of a few nuclei surrounded by electrons, and finally the structures of the nuclei in terms of two nuclear building blocks, the proton and the neutron. Thus, atoms, nuclei, and hadrons, subatomic particles with a strong tendency to interact with one another and transform into one another were in turn considered to be elementary particles. None of them, however, fulfilled that expectation. Each time, these particles turned out to be composite structures themselves, and physicists hoped that the next generation of constituents would finally reveal themselves as the ultimate components of matter. On the other hand, the theories of atomic and subatomic physics made the existence of elementary particles increasingly unlikely. They revealed a basic interconnection of matter, showing that energy of motion can be transformed into mass, and suggesting that particles are processes rather than objects. All these developments strongly indicated that the simple mechanistic picture of basic building blocks had to be abandoned. And yet, many physicists are still reluctant to do so. The age-old tradition of explaining complex structures by breaking them down into simpler constituents is so deeply ingrained in Western thought that the search for these basic components is still going on. There is, however, a radically different school of thought in particle physics which starts from the idea that nature cannot be reduced to fundamental entities, such as elementary particles or fundamental fields. It has to be understood entirely through its self-consistency, with its components being consistent both with one another and with themselves. This idea is known as the bootstrap hypothesis. Its originator and main advocate is Geoffrey Chew. The bootstrap philosophy constitutes the final rejection of the mechanistic worldview in modern physics. Newton's universe was constructed from a set of basic entities with certain fundamental properties which had been created by God and thus were not amenable to further analysis. In one way or another, this notion was implicit in all theories of natural science until the bootstrap hypothesis stated explicitly that the world cannot be understood as an assemblage of entities which cannot be analyzed further. In the new worldview, the universe is seen as a dynamic web of interrelated events. None of the properties of any part of this web is fundamental. They all follow from the properties of the other parts, and the overall consistency of their mutual interrelations determines the structure of the entire web. Thus, the bootstrap philosophy represents the culmination of a view of nature that arose in quantum theory with the realization of an essential and universal interrelationship and acquired its dynamic content in relativity theory. At the same time, this view of nature came ever closer to the Eastern worldview and is now in harmony with Eastern thought, both in its general philosophy and its specific picture of matter. The bootstrap hypothesis not only denies the existence of fundamental constituents of matter, but accepts no fundamental entities whatsoever, no fundamental laws, equations, or principles, and thus abandons another idea which has been an essential part of natural science for hundreds of years. The notion of fundamental laws of nature was derived from the belief in a divine lawgiver, which was deeply rooted in the Judeo-Christian tradition. In the words of Thomas Aquinas, quote, "There is a certain eternal law, to wit, reason, existing in the mind of God and governing the whole universe," unquote. This notion of an eternal divine law of nature greatly influenced Western philosophy and science. Descartes wrote about the laws which God has put into nature, and Newton believed that the highest aim of his scientific work was to give evidence of the laws impressed upon nature by God. To discover the ultimate fundamental laws of nature remained the aim of natural scientists for the 3 centuries following Newton. In modern physics, a very different attitude is now developed. Physicists have come to see that all their theories of natural phenomena, including the laws they describe, are creations of the human mind. They are properties of our conceptual map of reality, rather than of reality itself. This conceptual scheme is necessarily limited and approximate, as are all the scientific theories and laws of nature it contains. All natural phenomena are ultimately interconnected, and in order to explain any one of them, we need to understand all the others, which is obviously impossible. What makes science so successful is the discovery that approximations are possible. If one is satisfied with an approximate understanding of nature, one can describe selected groups of phenomena in this way, neglecting other phenomena which are less relevant. Thus, one can explain many phenomena in terms of a few, and consequently understand different aspects of nature in an approximate way without having to understand everything at once. This is the scientific method. All scientific theories and models are approximations to the true nature of things, but the error involved in the approximation is often small enough to make such an approach meaningful. Thus, physicists construct a sequence of partial and approximate theories, each of them being more accurate than the previous one, but none of them representing a complete and final account of natural phenomena. Like these theories, all the laws of nature they describe are mutable, designed to be replaced by more accurate laws when the theories are improved. It is evident that the complete bootstrap view of nature, in which all phenomena in the universe are uniquely determined by mutual self-consistency, comes very close to the Eastern worldview. An indivisible universe in which all things and events are interrelated would hardly make sense unless it were self-consistent. In a way, the requirement of self-consistency, which forms the basis of the bootstrap hypothesis, and the unity and interrelation of all phenomena, which are so strongly emphasized in Eastern mysticism, are just different aspects of the same idea. This close connection is most clearly expressed in Taoism. For the Taoist sages, all phenomena in the world were part of the cosmic way, the Tao, and the laws followed by the Tao were not laid down by any divine lawgiver, but were inherent in its nature. Thus we read in the Tao Te Ching, quote, "Man follows the laws of earth follows the laws of heaven follows the laws of Tao follows the laws of its intrinsic nature." Unquote. In the Eastern view, then, as in the view of modern physics, everything in the universe is connected to everything else, and no part of it is fundamental. The properties of any part are determined, not by some fundamental law, but by the properties of all the other parts. Both physicists and mystics realize the resulting impossibility of fully explaining any phenomenon, but then they take different attitudes. Physicists are satisfied with an approximate understanding of nature. The Eastern mystics, on the other hand, are not interested in approximate or relative knowledge. They are concerned with absolute knowledge involving an understanding of the totality of life. Being well aware of the essential interrelationship of the universe, they realize that to explain something means, ultimately, to show how it is connected to everything else. As this is impossible, the Eastern mystics insist that no single phenomenon can be explained. Thus, Ashvaghosha writes, quote, "All things in their fundamental nature are not nameable or explicable. They cannot be adequately expressed in any form of language." Unquote. To free the human mind from words and explanations is one of the main aims of Eastern mysticism. Both Buddhists and Taoists speak of a network of words, or a net of concepts, thus extending the idea of the interconnected web to the realm of the intellect. As long as we try to explain things, we are bound by karma, trapped in our conceptual network. To transcend words and explanations means to break the bonds of karma and attain liberation. The notion of all in each and each in all has found its most extensive elaboration in the Avatamsaka school of Mahayana Buddhism. The last part of the Avatamsaka Sutra, the scripture upon which this school of Buddhism is based, tells us the story of a young pilgrim, Suddhana. It gives the most vivid account of his mystical experience of the universe, which appears to him as a perfect network of mutual relations, where all things and events interact with each other in such a way that each of them contains in itself all the others. This passage from the sutra paraphrased by D.T. Suzuki, uses the image of a magnificently decorated tower to convey Sudana's experience. Quote, "The tower is as wide and spacious as the sky itself. The ground is paved with innumerable precious stones of all kinds, and there are within the tower innumerable palaces, porches, windows, staircases, railings, and passages, all of which are made of the 7 kinds of precious gems. And within this tower, spacious and exquisitely ornamented, there are also hundreds of thousands of towers, each one of them which is as exquisitely ornamented as the main tower itself, and as spacious as the sky. And all these towers, beyond calculation in number, stand not at all in one another's way. Each preserves its individual existence in perfect harmony with all the rest. There is nothing here that bars one tower being fused with all the others, individually and collectively. There is a state of perfect intermingling and yet of perfect orderliness. Sudana, the young pilgrim, sees himself in all the towers, as well as in each single tower, where all is contained in one, and each contains all." Unquote. The tower in this passage is, of course, a metaphor for the universe itself, and the perfect mutual interfusion of its parts is known in Mahayana Buddhism as interpenetration. The Avatamsaka makes it clear that this interpenetration is an essentially dynamic interrelation which takes place not only spatially but also temporally. Space and time are also seen as interpenetrating. The experience of interpenetration in the state of enlightenment can be seen as a mystical vision of the complete bootstrap situation, where all phenomena in the universe are harmoniously interrelated. In such a state of consciousness, the realm of the intellect is transcended, and causal explanations become unnecessary. They are replaced by the direct experience of the mutual interdependence of all things and events. The Buddhist concept of interpenetration thus goes far beyond any scientific bootstrap theory. Nevertheless, there are models of subatomic particles in modern physics based on the bootstrap hypothesis, which show the most striking parallels to the views of Mahayana Buddhism. When the bootstrap idea is formulated in a scientific context, it has to be limited and approximate, and its main approximation consists in neglecting all but the strong interactions of subatomic particles. The scientific bootstrap, then, deals exclusively with strongly interacting particles, or hadrons, and is therefore often called the hadron bootstrap. The picture of hadrons that emerges from the bootstrap theory is often summed up in the provocative phrase, "Every particle consists of all other particles." It must not be imagined, however, that each hadron contains all the others in a classical static sense. Rather than containing one another, hadrons involve one another in a dynamic and probabilistic sense. In the hadron bootstrap, all particles are dynamically composed of one another in a self-consistent way, and in that sense can be said to contain one another. The idea of each particle containing all the others has not only arisen in Eastern mysticism, but also in Western mystical thought. It is implicit, for example, in William Blake's famous lines, "To see a world in a grain of sand, and a heaven in a wild flower, hold infinity in the palm of your hand, and eternity in an hour." Here again, a mystical vision has led to an image of the bootstrap type. If the poet sees the world in a grain of sand, the modern physicist sees the world in a hadron. The bootstrap theory of hadrons is far from being completed, and the difficulties involved in its formulation are still considerable. Nevertheless, physicists have already begun to extend the self-consistent approach beyond the descriptions of strongly interacting subatomic particles. Such an extension eventually will have to go beyond present theories and include other concepts. According to Jeffrey Chew, these might include our conception of macroscopic space-time and perhaps even that of human consciousness. To quote him, Carried to its logical extreme, the bootstrap conjecture implies that the existence of consciousness, along with all other aspects of nature, is necessary for self-consistency of the whole." Unquote. This view, again, is in perfect harmony with the views of the Eastern mystical traditions, which have always regarded consciousness as an integral part of the universe. In the Eastern view, human beings, like all other life forms, are parts of an inseparable organic whole. Their intelligence, therefore, implies that the whole, too, is intelligent. Man is seen as the living proof of cosmic intelligence. In us, the universe repeats over and over again its ability to produce forms through which it becomes consciously aware of itself. In modern physics, the question of consciousness has arisen in connection with the observation of atomic phenomena. Quantum theory has made it clear that these phenomena can only be understood as links in a chain of processes, the end of which lies in the consciousness of the human observer. Some physicists argue that the explicit inclusion of human consciousness may be an essential aspect of future theories of matter. Such a development would open exciting possibilities for a direct interaction between physics and Eastern mysticism. The understanding of one's consciousness and of its relation to the rest of the universe is the starting point of all mystical experience. The Eastern mystics have explored various modes of consciousness through the centuries, and the conclusions they have reached are often radically different from the ideas held in the West. If physicists really want to include the nature of human consciousness in their realm of research, a study of Eastern ideas may well provide them with stimulating new viewpoints. Thus, the future enlargement of the Hadron bootstrap, with the bootstrapping of space-time and of human consciousness it may require, opens up unprecedented possibilities which may well go beyond the conventional framework of science. Again, to quote Jeffrey Chew, "Our current struggle with the Hadron bootstrap may thus be only a foretaste of a completely new form of human intellectual endeavor, one that will not only lie outside of physics, but will not even be describable as scientific." Unquote. Where, then, does the bootstrap idea lead us? This, of course, nobody knows, but it is fascinating to speculate about its ultimate fate. One can imagine a network of future theories covering an ever-increasing range of natural phenomena with ever-increasing accuracy. Imagine a network which will contain fewer and fewer unexplained features, deriving more and more of its structure from the mutual consistency of its parts. Someday, then, a point will be reached where the only unexplained features of this network of theories will be the elements of the scientific framework. Beyond that point, the theory will be no longer able to express its results in words or in rational concepts, and will thus go beyond science. Instead of a bootstrap theory of nature, it will become a bootstrap vision of nature, transcending the realms of thought and language. It will lead us out of science and into the world of acintya, the unthinkable. The knowledge contained in such a vision will be complete, but cannot be communicated in words. It will be the knowledge which Lao Tzu had in mind more than 2,000 years ago when he said, "He who knows does not speak. He who speaks does not know." The Eastern religious philosophies are concerned with timeless mystical knowledge which lies beyond reasoning and cannot be adequately expressed in words. The relation of this knowledge to modern physics is but one of its many aspects, and like all the others, it cannot be demonstrated conclusively but has to be experienced in a direct, intuitive way. What we hope we have achieved in this program, to some extent, is to have given you an opportunity to share an experience which became for Dr. Fritjof Capra a source of continuing joy and inspiration, that the principal theories and models of modern physics lead to a view of the world which is internally consistent and in perfect harmony with the views of Eastern mysticism. Once the parallels between Western science and Eastern mysticism are accepted, a number of questions will arise concerning their implications. Is modern science, with all its sophisticated machinery, merely rediscovering ancient wisdom known to Eastern sages for thousands of years? Should physicists, therefore, abandon the scientific method and begin to meditate? Or can there be a mutual influence between science and mysticism, perhaps even a synthesis? Dr. Capra believes that all these questions have to be answered in the negative. He sees science and mysticism as two complementary manifestations of the human mind, of its rational and intuitive faculties. The modern physicist experiences the world through an extreme specialization of the rational mind. The mystic experiences the world through an extreme specialization of the intuitive mind. The two approaches are entirely different and involve far more than a certain view of the physical world. However, as we have learned to say in physics, they are complementary. Neither is comprehended in the other, nor can either of them be reduced to the other, but both of them are necessary, supplementing one another for a fuller understanding of the world. To paraphrase an old Chinese saying, mystics understand the roots of the Tao, but not its branches. Scientists understand its branches, but not its roots. Science does not need mysticism, and mysticism does not need science, but men and women need both. Mystical experience is necessary to understand the deepest nature of things, and science is essential for modern life. What we need, therefore, is not a synthesis, but a dynamic interplay between mystical intuition and scientific analysis. So far, this has not been achieved in our society, but things are changing. In the past 20 years, we have seen an increasingly strong interest in Eastern mysticism, an interest that is part of a much larger trend which attempts to counteract a profound imbalance in our culture, in our thoughts and feelings, our values and attitudes, and our social and political structures. The Chinese terminology of yin and yang is very useful to describe this imbalance. Our culture has consistently favored yang, or masculine, values and attitudes, and has neglected their complementary yin, or feminine, counterparts. We have favored self-assertion over integration, analysis over synthesis, rational knowledge over intuitive wisdom, science over religion, competition over cooperation, expansion over conservation, and so on. This one-sided development has now reached a highly alarming stage, a crisis of social, ecological, moral, and spiritual dimensions. However, we are witnessing at the same time the beginning of a tremendous evolutionary movement that seems to illustrate the ancient Chinese saying that the yang, having reached its climax, retreats in favor of the yin. The rising concern with ecology, the strong interest in mysticism, the ever-growing feminist awareness, and the rediscovery of holistic approaches to health and healing are all manifestations of the same evolutionary trend. They all counteract the overemphasis of rational masculine attitudes and values, and attempt to regain a balance between the masculine and feminine sides of human nature. Thus, the awareness of the profound harmony between the worldview of modern physics and the views of Eastern mysticism now appears as an integral part of a much larger cultural transformation, leading to the emergence of a new vision of reality that will require a fundamental change in our thoughts, perceptions, and values. In mysticism, knowledge cannot be separated from a certain way of life, which becomes its living manifestation. To acquire mystical knowledge means to undergo a transformation. One could even say that the knowledge is the transformation. Scientific knowledge, on the other hand, can often stay abstract and theoretical. Thus, most of today's physicists do not seem to realize the philosophical, cultural, and spiritual implications of their theories. Many of them actively support a society which is still based on the mechanistic, fragmented worldview, without seeing that science points beyond such a view. It points towards a oneness of the universe, which includes not only our natural environment, but also our fellow human beings. The worldview implied by modern physics is inconsistent with our present society, which does not reflect the harmonious interrelatedness we observe in nature. To achieve such a state of dynamic balance, a radically different social and economic structure will be needed. A cultural revolution in the true sense of the word. The survival of our whole civilization may depend on whether we can bring about such a change. It will depend, ultimately, on our ability to adopt some of the yin attitudes of Eastern mysticism, to experience the wholeness of nature and the art of living with it in harmony.